All right, so this is Fly and Fold from Coding and Community. We're going to be talking about computer science and why it's important, what kind of jobs you could get in computer science, and then we're going to learn about algorithms and like get some hands-on experience with a fun way to do algorithms. I will share my screen. Okay, very nice. You can see it?
Yeah.
Okay, awesome. So let's go into the slideshow and let's begin. So this session is really about exploring computer science and just learning about the things you can do with computer science, the power of coding. And our group is called Coding and Community, so that's why it's on there. And okay, so why should I learn code? There's a lot of reasons that different people learn code, and maybe not all of them will relate to you, but there's definitely a reason for every person to connect to code and learn about it. And so we can go through some of the reasons. Coding empowers you. So if you've ever thought like, I really wish there were an app that could keep track of my grocery list or keep track of my classes. Right now, it's really hard to make it, and you just have to not have that app. But if you learn how to code and get really good at it, you can just make that app and make your life a lot easier. So it's really empowering to have that ability to make things that directly impact and help your life. Hello. So we just started, and we'll continue. Another reason we might want to learn how to code is it teaches you how to think in different ways. So it gives you more flexibility in trying to figure out how to solve problems. Because if you encounter a problem, you might have a better way to solve it because you know how to break it down and basically think about it as you would think about code. So once you get really good at coding, it really helps in trying to figure out how to solve problems. And honestly, it's one of the fastest growing jobs in the world. So a lot of people with computer science jobs, they're like getting hired immediately. They're getting really great salaries. And so it's like a really good career opportunity, and you'll probably be set for life once you get a good computer science job. And it really is really fun. Once you get into it, you might start making really cool programs that you'll enjoy and want to continue, and it'll be really fun because there is a lot that you can make, and it's really a good feeling to have made something and it ends up good. It's really cool. And Steve Jobs, the inventor of Apple and Pixar, says everybody in this country should learn how to program a computer because it teaches you how to think. So obviously he knows what he's talking about as the inventor of two big companies. And if he thinks that everyone should learn how to program a computer, maybe we should learn about it too. All right. So there's a lot of opportunities in computer science. As I mentioned earlier, it's really a fast-growing field. So computer science opens up a world of opportunities all around the globe. Like, these are kind of the hotspots for computer science. There's a lot of jobs in these areas that are listed, but there's really jobs everywhere, especially now because of COVID and the pandemic. It's all remote anyways, so there's so many opportunities for computer scientists to learn and just explore different parts of the globe and work with people from different areas. A lot of computer science teams are global. So you might be working with someone in China or in Europe or in South America, and it's really cool to interact with different people. And these are some of the big companies that hire computer scientists. So if you've heard of Microsoft, Bloomberg, Google, Instagram, and like all of those big companies that you hear about, they have computer scientists in the background. So have you heard of any other companies that you think might have computer scientists? You can put it in the chat or just ideally just shout it out. You can unmute yourself. Netflix, yeah, definitely. So there's something called FANG. So it stands for Facebook, Amazon, Netflix, and Google. So those are the 4 big computer science companies where a lot of really good computer scientists go. And so Netflix is a really good example. Hulu, yeah. Yeah, so that's a good example too, because normally you wouldn't think about it. At least I wouldn't think about Hulu having code in the background to make it work. I just think it's TV. So it's a good example to think about how that TV is getting to you. All right, so those are great examples. So these are all places you could work if you learned computer science. And within the New York capital region, there's GE, IBM, like a ton of really big companies. And a lot of students at RPI, at least, do part-time internships there or work there and then also do school. And it's really a good experience to work in those places because you learn a lot about code. Obviously, you don't have to worry about that right now because you don't have to get a job right now, but it's a good thing to think about for the future, like what you might want to do, what kind of company you want to work at. And you can tailor what you do in college, what you major in, based on what you want your life afterwards to be. And computer science opportunities are really growing. Like, there's a lot of jobs now because everything is shifting to online stuff. We're in the information era, and so there's a lot of data to process. There's a lot of computer science like jobs that need to exist in order to make these online apps or websites and process all this new data. So computer science jobs are really growing. The CS undergraduate students to open computer jobs. So in 2015, for every 1 student who was studying computer science, there were 8 jobs available. So it's definitely a really good field. So you'd have like job security in that sense. And 1.8 million job openings in 2020. So just 2 years ago, we had a really big number of jobs. And it's just good to think about like why it could help you. And one of the biggest issues in computer science is that the people working on code do not represent the demographics of the nation. So the big problem is like gender inequalities and racial inequalities. And one of the reasons that's really important is because it's important to even that out is because different types of people with different backgrounds come up with different ideas that can help people. So, for example, if something that affects women more, so maybe women like something that they would want an app for, but there's no women computer scientists. So it would be difficult for everyone's needs to be catered to. So that's why it's really important to get more of that demographics, to get more of the demographics of the computer science workforce to match the nation's demographics, so that everyone has a representation in computer science. And so here's just some graphs. Not sure if you can see the chat window, and so I'll move them to the side. But okay, so Google's annual diversity report. And you can go to this link and actually see for yourself if you wanted. So representation by race and ethnicity. There is, in the United States, there's very few Native Americans, but that matches, actually, yeah, there's very few Native Americans, very few African Americans, Latinx. There's a decent amount of Asians, and there's a big portion of white Caucasians. So this doesn't accurately represent the demographics of America. So we want to get that to match more so that everyone gets representation and gets apps and websites that help them, that help solve problems that they might face. Same thing for gender. Like I mentioned earlier, there's like 50% women in the nation, but only 31% of the computer science workforce are women, which doesn't add up because it should be 50-50, but it's not. So we need to encourage more people with different backgrounds to explore computer science and learn about it. Regardless of what your background is, what your education or whatever you think might be holding you back from computer science or any kind of technology company from STEM, it's super important to at least look into it, because whatever you think is stopping you from that, it's something you can overcome and you can learn about and end up with a really cool job and life. And many tech companies are working to increase diversity, and they're trying to make sure that everyone is comfortable and different people from different backgrounds are all represented. And a greater variety of perspectives collaborating on a product will help generate better, more well-rounded solutions. So some people with different backgrounds might think of problems that other people might not think of. So you just want to have more eyes looking at it and more diverse backgrounds thinking about the problem differently. And anyone can code with the right mindset. Even if you think you're horrible at math or which I don't think either of you are. I'm sure you're really good at math. And any of your school subjects, if you think you might not be able to, it's definitely something you can overcome. And regardless of what your background is, you can definitely code. You can definitely learn how to. And at this point, I will let Spia take over. Spia is our other instructor. I will stop sharing.
Yeah. Hello, I'm Spia, and I'll continue on with the presentation. I'll just share my screen. Can you hear me well, by the way? I'm not sure if I'm too quiet.
I can hear you.
Okay, that's good. So to continue on, what is computer science really? Well, as you can see, there are these three branches that are the foundation of computer science. So language is the first branch. Um, why? Well, computer science is a way for us humans to communicate with computers. And computer science also involves with math. Mathematicians also always use computer science to help with making theories and proofs, and you can also use computer science to calculate calculations. And then engineering. Computer science, you can use it to program hardware devices or create technology such as like robots to computers, and it involves a lot of engineering. So computer science has a variety of disciplines. And then you might be wondering, what do computer scientists actually do? Well, software engineering is a very popular career choice for CS majors because it's a growing career. Um, and you might be wondering, what is software engineering? And it's not just coding, there's more to that. Software engineers build systems with components, software engineers test code, make documentation, and they also involve in team organization. So as you can see, this quote says, "The art of managing complexity." As was mentioned before, coding is a mindset, and software engineers work with different people, work with different backgrounds and perspectives to all create a working software for their company. And then we also have product managers. Product managers, as you can see, it is in between UX, which is user experience, technology, and business. So it's right in the middle of all of these three fields. And what product managers do, they guide a product idea from design to implementation stages. So they deal with design goals, resources, setting deadlines, and they also listen to project stakeholders and find a balance between needs. So they are really like the the main group that ties in all of the different teams, such as like the software development team, the tech team, the all of the teams, the designing team, and like they tie all of these teams together to uh, produce a well done product. And then we have user experience designer. So you can see there's UX and UI. UX, as mentioned before, is basically user experience, and then UI is user interface. They're a bit different. So user experience focuses on the accessibility, usability, and learnability. A common UX design are buttons, which are used in everywhere from websites to TV remotes. That all involves with UX. And user interface is basically the layout and how the product is supposed to look to the user. And you can see there's a screenshot of a Siri page, and as you can see, there are two buttons. This is where user experience is involved. The user can choose which date, and they just click on it, and they know that whatever they click on will produce an action, and the computer will understand it. So product managers, software engineers, and user experience designers are not the only careers available to computer science. As you can see, there's a big list over here, such as data scientists, web developers, game designers, all the way to researchers and engineers. And there's even more than just these careers over here. So that's why computer science is a very popular field, because it attracts many job opportunities, and you can do, it's not only just about coding, you can do many things with it. So the main topic of our presentation is our algorithms, and we'll be creating our first algorithm, but before we do that, we need to understand what is an algorithm. So an algorithm is a series of instructions that a computer follows to achieve a task. So can anyone give any examples of real-life algorithms? And you can just type it in the chat or unmute. And if you don't have any, I can give you an example. For example, a recipe is an algorithm. A recipe has a list of instructions where the person follows and they just create the meal that they want to make. Yeah, a load gamer file is also a good algorithm. Another example, we can say a GPS. A GPS is where the GPS gives you instructions that will help you reach to your destination, such as turn right, turn left. Those are different instructions for the algorithm. And also, algorithms doesn't have to only involve like explicit text, but like for example, even a traffic light is another algorithm. Whenever you see the color green, it means to go. Whenever you see the color red, it means to stop. So you see algorithms everywhere in real life. And so why are algorithms even important in computer science? Well, if you don't give a computer instructions, the computer is kind of useless. For example, let's say you're thinking in your head, I wonder how the weather is outside. The computer's not going to know what you're thinking. You need to search up on Google, what is the weather? And then the computer can respond and give you the answer. So without instructions, the computer doesn't know what it needs to do. So now we're going to dive into our first algorithm, fold and fly. Part one of this algorithm is if you can find a partner at home, that'll be great. And if not, you can also do this by yourself. And once you find a partner, the next slide, you're going to choose 6 steps to make a paper airplane. So if you do have a partner, choose these steps for your partner. And if not, you can just make these steps for yourself. So I can give you like 2 minutes if you want to like find a partner. And if not, that's all right.
Well, since we have 2 people, if you want to write like steps for each other and exchange the steps, you can do that too.
Yeah, that works as well.
Maybe we can also join in and write steps and like switch up the steps.
Okay, yeah. So I guess I can show the steps right now. So like how are the partners going to work? Are you guys going to work together, or did you guys find someone else that you want to work with at home? You can just like type in the chat. It seems like no response, so I think we can just like work together. I think that's a good idea. So as you can see, there are 8 different steps over here. And we need to make an algorithm that contains 6 steps. So, and these steps aren't in order, so you have to make sure to focus on the sequence of steps as well. So you can just like, if you have a piece of paper or even like a Google document, you can type in the steps and think of your algorithm for how to make a paper airplane, and then type it in the chat for you guys to share. And then we'll be following, for example, Nyla, you can write an algorithm, and then Razak, how do you pronounce your name? Sorry that I might have butchered it, but you can make
It's Razak.
Oh, Razak. Okay. Razak, you can make an algorithm for Nyla. So I think like 3 minutes is a good enough time for you guys to make an algorithm.
You can let us know if you finish way before 3 minutes.
Yeah, definitely. Once you put it in the chat, then we know you're done.
So yeah, maybe I'll make one for you. Then you can make one for me.
Yeah,
I'm gonna make it as horrible as possible. Exactly the wrong steps.
Yeah, 6 steps. And if you want to like use any other step that's not on the slide, feel free to do that. Okay, I see your algorithm. So fold the paper in half. Okay. So that looks good. So I just need to wait for Nyla to make her algorithm, and I guess whenever you're ready, Shweta, for your algorithm too. And then we can get started. Oh, that's okay. You just need to um like write it for now. You don't need to actually fold the paper because then you'll be using someone else's algorithm. Whenever you're done, Nyla, like writing these steps, just like type it in the chat so we can start making the airplanes.
I already made the airplane. I'm just like typing the thing now.
Alright, that's fine. No rush, by the way. I was just making sure.
Sophia, if you want to demonstrate, like, going through the steps while Nyla finishes up. And yeah, no rush.
Yeah, I guess I can demonstrate your algorithm while we're waiting. So I'm gonna use like scrap paper. Let's see. So the first step actually, oh, you can't see because of the background. I'll get rid of my background. Okay, don't mind the whole mess. Okay, so the first step, Shweta said, is fold the paper in half. So I'm gonna fold it. Oh, it didn't get rid of the background. I'm gonna try it again. Apply. Okay, so fold the paper in half. And then rip corner of paper. So I'm gonna rip this corner. And then unfold, so unfold, and fold the corners into the center line. Alright, so I'll fold it like this. Fold the other side. So this is what I have over here so far. And then I'll fold the plane in half. So I guess like this way. And then crumble the paper. Alright. So I crumble the paper and then fold the top edges to the center. So the top edges I guess right over here. So after following Schweizer's algorithm, this is my paper airplane. So now it looks like Nyla and Razak, you both got your algorithm, so I guess you can look at each other's steps and create your own paper airplane. And then when you finish your airplane, just type it in the chat or unmute that you finished it, and then we'll move on to the next step of the presentation.
If you're able to, it would be cool if you can turn on your cameras and show us your final product, but you don't have to.
Oh yeah. Alright, Nyla, it seems like you're done. So we'll wait for Zach and then we'll be good to go. And if you want to share your paper airplane, like Shui just said, feel free. Oh, okay, so both of you guys are done with your paper airplanes. So, Shui, did you do yours yet?
You can start. I'll keep working on mine slowly.
Alright, yeah, no rush, no rush. Okay, so, yes, okay, yeah, that's fine. We can always talk about the airplanes too. Let me present. So now you guys made your first algorithm, or maybe this isn't your first algorithm, but now our next step is to, fly the airplanes. So make sure you're in a safe environment and there aren't that many obstacles in the way, or anyone to get hurt by your airplanes, but feel free to throw your airplane. Well, you can let us know how it goes. And if your airplane isn't working, or if you find any trouble with making it fly, that also is helpful and you can let us know in the chat or unmute. Alright, that's progress. I guess it did stay in the air, but it also fell. So I guess the airplane might need some work. So it just like you threw it and then it just fell. It didn't it didn't travel that much, right? Not even 2 feet. Okay, that's alright. At least we went in the air. Okay. And then Nyla, you can let us know how yours went. And then I guess while we're waiting, maybe you can like figure out a way to make it stay longer in the air. Maybe like edit the algorithm. Okay, so Nyla said that it flew pretty well. It was a couple feet off the ground and then stopped and fell down. All right, that sounds good. That means your airplane is working well. So maybe, Razak, maybe you can share with us maybe a reason why it just like flopped in the air. Okay, your airplane also stopped in midair. All right, so there might be an issue with our algorithms for why it just flops in the air. Okay, so you didn't fold it correctly. All right, that kind, I think that makes sense. That makes sense. It's all about the folding. It's a really crucial part to making a good paper airplane. Okay, so I'll move on to part 3 then. Part 3 will make it even harder for your airplane to fly. If you have like a paper clip, you can like attach to part of the plane. Maybe it might help it fly up, but I kind of doubt it. It's just to add a little weight to your airplane. And then if you want, you can just like refold the paper airplane, or you can even start from scratch and then attach the paper clip so it can like stay in the air longer and not stop in midair, like the issues you've been having. Like find a way to improve your paper airplanes. Oh yeah, Shweta, did you try or did you finish your airplane?
I did. Yeah, I'd say it went like 2 feet.
2 feet? Alright. That sounds like average. I didn't start I can throw this and see how far it goes. I would say the airplane that I threw, it didn't like stay in the air that long. It's more like throwing a ball. So it did kind of make some distance. So it's like I would say it made like 4 feet, 4 feet. Yeah, so
Yeah, like Nyla said, it didn't fly, it just fell.
yeah.
So, so that's kind of an example of if an algorithm goes horribly wrong, if you have everything in the exact wrong steps. So you all did better than I did in making a decent algorithm.
Yeah. As you can see, the better the algorithm, the better result you'll end up having. And also, if you aren't specific with your algorithm, like for example, when you say fold, you know, the user needs to know what do you mean like how should I fold it? Maybe so the more specific and the better algorithm you write, the better result you get. Oh yeah, do you guys have paper clips with you guys? Like did you try attaching it with your airplanes? And if not, I'll just assume that you guys didn't have any paper clips. And I have another question for you guys. If you guys can think of a way to change your algorithm, like if you're gonna change one step, what would you write instead of this? Like what would you write instead? Like how would you change the steps that you were given already to make it easier? Maybe make it more specific, or maybe change the order of the steps. For example, if I were to change Shweta's algorithm, I would change where she says crumble the paper, and instead I would say after folding the plane in half, I would fold the top edges to the center and leave it at that. That's my way of changing the algorithm. So yours is crumble it at the end and maybe try it at the end too. Yeah, you know what? I think that's a way we can change your algorithm. See if you can try that, Nyla, and see if your paper airplane flies farther too when you do that. Maybe you can like, yeah. Okay, yeah, you can do that.
Also, if you have like a pen, you can try attaching it to like the side of your paper. So, or something that is heavy enough that'll actually stick on there.
Oh yeah, in part 4, like you can even use a coin, like a penny or a quarter, on top of the paper clip. It might be too heavy, but anything that you can attach on.
You can even experiment with different types of things, like maybe a quarter will give you different results than a penny because they're different sizes.
Yeah, or you don't even need to use paper. Maybe you can use like foil or something like that. Maybe that'll fly farther. Oh yeah, did you guys try like ripping it? Did it or crumbling it? Did it help it go farther or stay in the air longer? And there's no rush. Yeah. Well, I am a computer science major at RPI.
I am not. Keenan is not. I think Rohan is.
Yeah.
But like every major should learn a little bit of computer science. Like, yeah. I'm a chemical engineer. I spend most of my time coding. So every whatever you want to do, even if you want to be an arts major, like you'd think there's nothing related there, but there is a use for computer science in art and in every major.
Yeah. All right, that sounds cool, Nyla. I guess you changed your algorithm and you got a better result, and were able to keep the coin on the paper airplane. So I guess we can move on to. I mean, we did the discussion. We did discuss about how our airplanes worked. So we can just do a. Uh, yeah, we can answer these questions if you would like. So, what else can you use algorithms for in your everyday life, and how can algorithms help us with problem solving? You can answer one of the 2 questions and type it in the chat. Yeah, that's a good answer. Math or science. I guess, like, for example, math is like when you're solving an algebra equation, maybe you'll have an algorithm that says first list all your known variables, your unknowns, and then set up the equation. So yeah, an algorithm can help with math and science. And then Razak, you said you'll have to think about the first question. For the second one, I think algorithms can help us deduce where we went wrong in a problem. Yeah, that does make sense because when you write your list of steps and then maybe the result didn't turn out how you expected it, you have something to look back into, like, in reference to see where it went wrong. So that's a good answer. And then Nyla, you said if you do one step and can't find an answer, do something else. Yeah, that's basically like what we did with our algorithms too, because it didn't go well. So we found another answer to how to make our airplane fly longer. And then Keenan said code is used all the time in the sciences. A lot of scientists end up jobs as programmers in other industries. So yeah, that is very true. Yeah, it is basically like an error in a code reset. So yeah, you guys all have really good answers for both of these questions. I would say one thing for my answer for number one would be just like setting up a schedule and a planner is just an algorithm for me because then it like helps me accomplish everything that I have to do for today and yeah, to keep me my day more organized. So thank you guys for listening to our presentation. I guess we have a little time to do a Q&A session. So if you have any other questions, feel free to type it in the chat or unmute, and we would be happy to answer them. And it can be like any type of question that you have. Oh, I am 18 years old. Maybe my voice is a bit, high, but yeah, I'm only a freshman at I'm a freshman in college. Yeah, 18 years old. I would say the best way to learn a new language is obviously start from the basics and I would say like experimenting with code. There are a lot of free resources online like YouTube with like crash courses for specific languages. If you would want to start coding, maybe start with Python. Khan Academy is also a good resource. But yeah, like I would say Python is a good place to start if you want to learn programming. And yeah, you can follow the resources online. That sounds great. Yeah, Shweta posted a link that can help you get started with learning Python. Oh yeah, so I guess you've done some like web development and now you're onto Java. Java is also a good language. I guess you can like, yeah, Java is really used in a lot of jobs and it's a good language to continue on off with. What class are you learning Java in? How did you start? That was the first programming language I also learned, Java. Oh, that's pretty impressive. That's cool then. I guess you can always stick with Java for now. And then once you like learn your first language, when you start learning another language, it becomes very easy because they all like use the same concepts and foundations. So like for example, functions, if else statements, you find that in almost all programming languages that are out there. So yeah, and that's pretty good that you're learning on your own. You're like one step ahead of everyone else. Yeah, so I think they should look familiar. Like Java was my first language, and then when I switched to Python, Python was pretty easy too because I use the same concepts that I learned from Java. You might even find it a bit simpler. So I guess if you guys have any more questions, feel free to chat. If not, thank you guys for coming. I really had fun talking to you guys, and I hope you've enjoyed making your algorithm for a paper airplane. So yeah, thank you guys for coming, and good luck with your if you want to code more. Good luck with that. Bye bye. Yeah.